Seems to be okay. All right, I'll just slowly get going. Because folks are still coming in. Let's put that there. All right. So, hi. Hello. All right. So my name is Alex Schreyer. I'm actually just from down the road here. I'm in the design building. And I'm heading up a program called Building and Construction Technology. So I'm coming more from the architectural, engineering, construction side of things. But there's a geek in me, so don't worry. and I want to talk a little bit about combining those two things. And there's actually quite a bunch of interesting things you can do. I'm gonna talk about one particular piece of software in this case, SketchUp, but. There are others in this space, of course, too. So there are some of these things that apply to other software as well. But just a really quick one. Who's worked with SketchUp here? Some? Okay. Other architecture, engineering software? Which?
AutoCAD.
AutoCAD? Yeah, AutoCAD.
TurboCAD.
What's that? TurboCAD? Okay. Then I know on the 3D modeling side, a bunch of folks are into Blender. Anybody here Blender? Okay, all right, yeah, okay. I think Blender is too complex for most architects and engineers. The user interface at least, but no, it's a great software too. So I want to talk about going beyond the 3D modeling, because most people use that software for 3D modeling buildings. How to put things together and going either conceptually or being detailed and so on and so forth. But SketchUp particularly has the opportunity that you can code things. You can write your own scripts in it. And it's actually in Ruby. And I'll show you a little bit about that, even if you haven't heard about or worked with Ruby before. So I'm combining 3D modeling with coding. It usually does make sense to do either or, because some things are easier when they're coded. And some things are easier when they model. And then I like to print things, so I got a few things here. Since we got this really great 3D printing lab on the 3rd floor of the library here, which our students have used extensively, that's a really nice workflow. You can expand this, and I actually don't have it in the slides here, but we also have the Trimble Technology Lab in our building. And Trimble is the owner of SketchUp now, but they also make other things. They make laser scanners, surveying equipment. And so we do have a laser scanner, for example, where we can scan this room, model that room, and then 3D print that room, if we wanted to. So there's even more than this workflow, but we're going to do this, and we're going to make SketchUp do this now. All right. Just about me, I teach courses in building information modeling is a big topic there, but 3D, structures and materials courses as well. And I've written a book on SketchUp and one on residential construction. So what I wanted to do here is, first of all, give a brief intro of how SketchUp fits into the workflow, especially for those that haven't worked with it yet. What can be done with it? How do you code with it? And how to make that easy, because I'm a lazy coder. I like easy. Anyways, and then I'll actually do some live modeling coding right here, so you can see how this works. Later on, or at any point, feel free to try this out yourselves. Most of this can at least be started for free. And then I'll show you how to go to 3D printing here. Oops. So about SketchUp. So just how everything fits together. In the building design phase, the first one is a conceptual design, where you're trying to figure out, what's the building shape in relation to other buildings, where do the functions go within the building, et cetera, et cetera. So that is done typically in, the more freer 3D modeling apps. So SketchUp is a great one. Another one is Rhino. Has anyone used Rhino here? So architecture students love Rhino. That's another software that does fairly similar things. But then in SketchUp, there's actually 2 versions of it now. And I'll hope I can pull both up later. One is an installable version that goes on your computer. It's called SketchUp Pro, where we actually have a campus license, so if anybody wants it, let me know. Then the other one is an online app. So thanks to WebGL, because that's in every browser now, they were able to basically port the entire thing over to the online app, which is great. And I'll show you that too. The only downside there is they haven't figured out how to do the coding part yet. They're working on it, I know, but they haven't figured that out yet. Anyway, so that's this first part, either conceptual design or even detailing, because some of the detailing stuff you don't do in some of the other software. On the building design side, the big software used by every architecture firm, construction firm out there, every single new building on campus is planned in it, is Autodesk Revit. And it's a parametric modeling software that then spits out all of those plans, basically. There's others. AutoCAD you already mentioned, ArchiCAD, Tekla, so there's other kind of production pieces of software. And then there's other software that's used either for analysis, like energy analysis, fabrication. Most of the structural parts in the design building were all CNC cut, and they were fabricated right from the software. So that is another thing. And then of course the construction process, how you procure things and so on. Anybody seen this building before? Have you all been there before? Yes. If you haven't been there, it's at the end of the street. Well, actually, it may be locked today, but if you come any other day, or I'll let you in if you behave. So it's a great building for a variety of reasons. But this is the conceptual design from the architects. I went into the old plan set. It was in one of the early meetings where they showed us roughly how it looks like. We started pushing things around, rearranging things. They were thinking about, for example, a louver system on the outside that then got changed later in the design process and so on and so forth. So the design building was planned originally in SketchUp and then moved into Revit. You can do a ton of other things with it. Anybody got an idea what this is? It's not a ship.
Skate park.
It's a skate park. So you can design it in SketchUp. Again, you can do this in other software too, but in SketchUp is where this is done. And then you cut all these pieces out of that, and you can figure out, angle cuts and all of that kind of stuff really nicely in the software. Furniture makers like using it because it's the idea of virtual construction or virtual manufacture. You go through every single little piece on the computer, and then when you make it later, it's going to fit. And even if you do this all by hand, even if this is not a CNC cut process, it's a really great way to plan this. And you can do mechanical systems, mechanical parts. The picture on the top right is an open source laser cutter. Don't remember where I got that from, but it's out there. Somebody basically planned all of that in SketchUp, all of the parts, anything from the acrylic to the wooden parts. You can download the plans. These kind of 3D fixtures are plastic fixtures that are, of mechanical sorts. That's really easy to do. And I just had my group of students do an assignment where they were supposed to just design and build something that's useful for them. And I got a few phone stands, it's always phone stands, but all kinds of other things. And it's really interesting to see, how folks that have never done this process within a week actually come up with something that's useful. Okay, so that's what you can do in SketchUp, and then the different stages of planning, whether you plan cuts and measure things, whether you slice things up in the software so that you can easily fabricate them, or whether you unfold things, that can all be done in the software. So that is a really great way to make things easy. If you're a sheet metal fabricator, you can go from a 3D piece to an unfolded shape very, very quickly, and then have it cut, basically. And then for the actual digital manufacturing process, whether you're CNC cutting, laser cutting, or whether you're 3D printing, that's just another step in the whole process. There's usually a fairly easy way to get the data from the software into a processing software that can then run the machines. And I'm going to show you today how you can do that for 3D printing. And actually, you can just walk over to the library afterwards and ask them to print something. So it's fairly easy. It's fairly easy to implement. So now the coding part. People keep asking, why would I want to do that? Doesn't SketchUp have great 3D modeling tools? And when you open the software, you got all the standard tools in there. If you need something, there's a tool that rounds edges. If you need something that's not in the software, it's a good chance somebody has written an extension and you can pull it in and you can work with it. It's really good. But sometimes you want to do something that it's not easy to do this way, or it's not efficient to do this way. So then parametric or any odd geometry is a good reason. Customizing input and output, if you have a particular data source that just doesn't translate easily, write a little import script that pulls that data into the software. Analyzing, this might be more the output side. You model something in SketchUp, and then you send it out to your analysis software. And then, and this may be why you're here, learn to code. There's tons of opportunities out there to learn to code. Wouldn't it be cool if you can do that and then print something? All of a sudden your coding exercise is physical. So that's a really cool implementation. And many schools, for example, are implementing both learn to code curricula and 3D printing, 3D modeling curricula. Why not combine those? If you get a little further with the whole thing, you can actually write your own tools for the software, so you can do that too. And I've done that a few times. But again, the way I like to see it is, I want to combine modeling with coding. There are some things that are easy to model, and some things are just impossible to model, so you want to write a little script for it. Okay, I'll show you a few examples. So this one, it's just a simple example, nothing too fancy. But it is something that would be hard to model by hand. You've got a curved facade in this case, and you basically want to vary the aperture size by the direction to south. And that's a really easy script that you can implement in no time. and you can model then off that. You can use that as a basis for modeling. You can keep doing any kind of parametric responsive things, a facade that changes color based on how close something is. Maybe no. I don't know why these people would change the color, but just as an example. Parametric geometry that kind of changes and undulates and so on and so forth. This is another thing that I actually forced my students to do, which is to build a MOBOT. I do that exercise every year. I approach it from a structural side, and those of you that may have a structural background can already see that this as a free body diagram. It's basically a structural element with loads on it and so on and so forth. And if you can plan that in the computer and find centroids and all that kind of stuff in the computer, and in theory it should work, but it hangs like this, then yes, your calculation was wrong. But anyway, so that's another way you can use it. And I actually wrote a script to find the centroid in SketchUp. This is where it gets a little more, building geeky side. You understand it. But basically, when we build buildings, we're putting a lot of data into these models nowadays. And this is something that wasn't done years before, but now our building models are not just 3D representations. So a column will have a definition and most probably a ton of other data assigned to it. And that kind of stuff, putting that into the software and getting it out of the software, often requires like a custom script or importer, exporter, and so on. And you can streamline that by coding. Have I convinced you yet? So, how do we code in SketchUp? So the main thing is there's two interfaces. One is a C API, so if you're a C coder, that's what you want to do. I like Ruby. Now, question, who's worked with Ruby here? Program Ruby? Hey, good. Okay, cool. It is the language that's implemented in SketchUp. For whatever reason, they picked Ruby at the time, but I have grown to like it because it's readable, it's understandable, it's got a nice, simple syntax, and I'll give you the basics of it in a second, but don't be afraid of it, basically. So Ruby is built in, and I'll show you an interface how you can script that really easily. C is a little bit more involved if you want to add that or create something with it. But basically, any functionality that's in the software is available. There's an API, everything's nicely documented. There are little script examples for everything. If it's in SketchUp one way or another, you can control it with a script. So that's a really nice feature that they have. And with every new release, they basically add a few new things. There's the documentation. And I'll put that. That'll come up in a second again. But if you go to the SketchUp website, you can go right to the developer side, and it's all nicely documented. How do you actually code? How do you write the code? Well, you could do that with external editors, and you most probably have used a bunch of those. Most of the external ones need to be bridged into the software. It's doable. You can actually use any with a debugger, basically. But the way I like to use it, usually my projects are not too extensive. So for bigger projects, that might be what you want to do. If you have smaller projects, or if you just want to do like an on-demand coding kind of thing, there's some built-in internal editors that you can download as extensions. And I wrote the second one, the Ruby code editor. And you'll see in a second. That's the one that I use, and a bunch of folks use for this, basically. Sounds easy, right? So this is how it looks like. And I'll open the software and I'll show you live in a second how it works. IDE-wise, something fairly minimalistic. Anybody know Code Mirror? Has anyone worked with that? Yeah, okay, so that's what I patched into that, basically. You can write your code, execute it, get something in there. Now, this is just the triangle example, but it's got, the basic functions. People keep asking me for more functions, and when I have the time, I'll put more in there. But it'll get you there. And then when you need to look up the functions, methods, classes, all of that kind of stuff, of all the stuff that's built in SketchUp, if you go to that ruby.sketchup.com website that I showed earlier, you'll get this here, the standard library of things, and you look it up, and everything has a nice little example to it. So it's really not that hard to learn. So those of you that haven't worked with Ruby and want to just try this out, don't be discouraged. Just try it. Because first of all, it's well documented, but Ruby is fairly readable. I'll show you in a second how that works. I really like snippet-based coding because that's I'm lazy and I always have to look things up. So I go to the website, find what I want, take my little snippet, pop it in there, try it out, and modify it. Like I don't know, many people do. Then, of course, you can always look at the source for a bunch of other of these extensions. Many of them are out there, so that's a really great learning opportunity. And then there's a community as well. As most probably everybody in this room, I've spent some time on Stack Overflow. But specific to the SketchUp community, there's Sketchucation, and SketchUp has their own forums, and those are really helpful too. Let's see. We got until 1:45, right? Okay, so just a really quick one. I'll just run through this very, very quickly. But the way that Ruby works is basically it's object oriented. You have something, you want to do something with it, so you add the method with the dot. You put a bunch of parameters in there. What I really like about Ruby is there's usually multiple ways to do things, and it's fairly forgiving actually with a bunch of things. And so you can do that. Hey, no semicolon. You can chain things, one method, another method, and so on. And if you need to change the object itself, then there are these kind of functions. Anyways, just for the sake of time, I'll just skip over this. We can see that in a second. So I want to show you how this looks like. Okay. So this is now in SketchUp. Like I said, this is SketchUp Pro. This is the local version on my computer. I installed the code editor. I can show you later how that gets installed. And then once it's in there, you can always either interact with things in your modeling environment by indexing things, or you can just highlight something and then write a script that does something to what's highlighted. So let me show you very, very quickly how you can do this. So what I have here, basically, these are all just little boxes, nothing too fancy, just as an example, basically. But I'm going to highlight them all. And now in the editor, I'm going to pull in a script. And you'll see those scripts are not very long, but might as well just run it. Ta-da! Let me show you another option. Just going to change it there. There you go. So, really quick explanation of what's happening here. There we go. So, in the script, I'm basically grabbing the selection. This is what I have selected in the model in this variable. Then I'm iterating through that. I'm saying for each of these boxes, do something. Now I put a little check in here whether it's actually a component, just so that it doesn't do funny stuff. And then it finds the position. So geometric things like position, width, length, parameters are really easy to use. And then I just scale by some function. And in this particular script, I've got the square, parabola, and a bunch of things in there. But then down here, I grab that function right there, and I transform each of these boxes by scaling upward. That's why only the third one is up there. And that's it. So that's a fun way to model and code, and I like it this way too because I can iteratively code. I can, like I just did, I run it one time, I create something, if I like it, I make a copy, put it on the side, run it again with another parameter, try something else, and then I might end up with a bunch of different versions that I can then play with. Let me show you one more thing here. Yep. Okay. So this operates on the same thing. It's a bit of a longer code, but what I want to show you here is that when I need it, and yes, I'm so vain to put my own picture there, but I couldn't find anything else. You can actually interact with other things on your computer or whatever. You can load from the file system, basically, write to the file system, interact with the user, like I just did, basically by popping up an open dialog. And then, this is just a little more involved, but basically what it does is it goes to that image, finds pixel values, and then plays with the height that way. So that's that. Okay, let me show you. Let's go back to our functions here. And we're going to do our parabola, because now I want to show you how to make that 3D printable. Okay, so there's that. Now, printing from here it's a little involved topic, so I can only skim the surface right now, but you can make a mental note already. In order to be able to print something as a solid shape, it has to be solid. So it has to have an outside, and it can't have funny geometry around. SketchUp is a surface modeler, so you got to be a little careful there because you're going to have surfaces between each of these units here. So fortunately, there's a tool for that I didn't even have to write. So I'm going to go to Tools, and I'm going to highlight everything that I had there. Click on Outer Shell. And what that does is it basically just wraps the whole thing, keeps only the outer shell, and makes it 3D printable. There's different tools that you would want to use to check whether something's 3D printable. And if you do this from another CAD software that is already a solid modeler, then you don't have to do that because it's already solid. But nevertheless, that would be the process here. So now you see nothing, all of the lines went away. If I actually turn my X-ray vision on, right here you can see this is what's called now a watertight solid or a manifold. And then the last check that I would want to do in SketchUp is whether it recognizes that this thing has a volume. And that's just a way for, in the software to see that it's a solid. So now I know, okay, well, this would be 3D printable. Mind you, what is it, 1,000 cubic feet? No, inches? Oh, the library's going to love me for that one. But anyways, so now you could either scale things here, or you can scale it on the other end. I'm just going to scale it on the other end. So I'm basically going to just highlight this piece. So I've file, where are we here? Export 3D model. And the file format that you want is STL, stereolithography. And the options here, only the geometry, pick millimeters. The printer's like millimeters. And that's it. So at that point, I've exported that in a file format that the library can use, that the 3D printer likes, where you can then pull that into the 3D printing software that slices it up basically into these layers where it builds it up. And again, you would have to scale it on the other end in this case here. So that's how that works in a nutshell. Just wanted to quickly show this here. How can you do it? Well, so first of all, you have to get SketchUp Pro. Didn't put that on there, but it does not work with a web version. But when you have it, if you're here on campus and you need a license, write me an email and I'll send you the campus license. But it starts as a trial anyway. So then within SketchUp, go to Windows, Sketch Warehouse, find the Ruby code editor, and just download it from there or install it, and then you can find it. The code examples that I just showed you are actually under my blog, under the tutorials. Just one of the recent ones. You can find them really nicely. I also, from my book, have all the scripts online. You can just download those as well from there. And you can do those things. I didn't show you too many of those, but here are some ideas. Just if you were to use this as like an intro to code thing, you can do something simple. Draw an H on the ground, Doesn't have to be a solid. It can be just lines. And any of those kind of things, draw something randomly sized, use the random function in Ruby to create something, random geometry. It's always fun. So there's all those things. So I think I'm on time. Hey. All right, so I wanted to give you a chance to ask questions. And then, of course, I've got these here. You can look at them afterwards. So this is just a vase. That's a certain building that I may have talked about. And then this, if you look at it the right way, is my daughter's outline. So, yeah, any questions? What
is the material?
Oh, the material here? This is PLA plastic, which is a biodegradable plastic. It's what our spoons and forks are made of. But if you go to the library, that's what they're going to be printing in. You can print in other materials. So there's ABS. Plastic gives you a little more strength if you want to make a tool, for example. Or, you can even print in metals. If you don't have access to a 3D printer, there's Shapeways. Shapeways is one of those websites where you can order things. There's a bunch of them out there, but that's one of them. Yeah.
There's also a Reddit subreddit that you can submit, and people sometimes do it for free.
And they just do it?
Or
Cool.
they'll do it for the cost of shipping or something like that, because they love using their 3D printer, and they're
That's good, as long as you don't ask for more than 5 kind of thing. Well, there's, what is it called, Make XYZ or something. There is a community out there of local makers, and then for CNC cutting, there's 100,000 garages, which is basically local makers, and if you need something done, you send it to them, and for those you have to pay, I know that,
Yeah.
so try yours first. Any other questions?
How big can you print? Like, how big is?
So it depends on the printer. Yeah, so if you go to the library, it's I think about 6 by 8 by about 8, I think. They have a large one, but it really depends on where you order it. So and it can be really time consuming. So even moderately sized prints, if they are very intricate with a lot of corners, they can easily take a night.
Yeah,
So-
I saw one being printed. I did a website for a beer taps manufacturer, and they
Right.
design the big long beer tap things.
Yeah.
And it's a resin, and I saw it being printed. They said it takes 24 hours for it to.
Yeah. And that's a really nice
Full
one.
beer tap.
Yeah, I'm gonna have a beer before that. So that's a really nice one. They're out of Cambridge too. Formlabs. They make a 3D printer, which is basically there's a resin bed and a laser hardens the resin, and then it just it pulls it basically out of the resin.
That's what I think this
Yeah,
was.
and can make even finer detail than what you see here. So this is 0.2 millimeter layer height. That's even finer, and it's really good quality stuff.
Yeah, they use it to make the mold, and then they manufacture.
And even with this here, it's actually often used as mold making, which, in terms of strength and internal strength, like metals, you can't get there, as good as if you cast it. So in that case, make a mold this way and then cast to it. Yeah.
Yeah, I've seen that used for ceramics.
Yeah.
One at Hammerly Ceramics, I think, is one that uses, I think he uses AutoCAD, but probably could also use SketchUp to make the molds, and then he just pours in the the
Does it leave the
clay.
plastic in with it?
No, he uses it for actual clay.
Oh, yeah, okay. Because I've seen
But
somewhere
the
where.
molds are plastic, yes.
Yeah, exactly. Where then they pour into basically burn the plastic out in the process rather than having to take it this way. And it's really interesting which materials you can make things from. So actually, it was really funny because my class was around Valentine's Day, so I told all the students, "Hey, got a new way to make something for." Yeah.
There is a chocolate printer. Yeah.
I want that.
Oh, I bet the chocolate doesn't taste very good. I bet. It doesn't exist.
So, I mean, on YouTube, there's tons of videos of that. Concrete is another one where people have been dabbling with. Well, it doesn't taste as good. Yeah.
So I'm new to a lot of this. Is there a way to scan an object to get the design in?
Yeah. So if you have a fairly, any kind of scale now. If you're here on campus, are you on campus? No. because our library would have just for everybody. So, but there are different ways. So there are some apps even that you can download where you take photos around something and then upload it, and they'll give you a 3D mesh that you can then print. The cost goes up with quality, basically. So if you want really good quality, it can get
Quality
quite
for
pricey.
the final
Yeah,
scan?
whether the surface quality is really perfect. Like if you're doing a museum replica, you would want to go with one of those high quality, high price ones. And if you want color, that's registered to the surface and so on and so forth. But there are photogrammetry applications, and you can always, you will have to take a lot of photos around something. But there's apps and websites that will make, mesh from there.
Do you teach this? Do you also do this privately? Do you have clients?
Well, my daughters.
I know his wife had a nice balance. Right.
If you want to call them clients. No, this is more, no,
Educational purposes?
more educational.
And what was the coolest thing that any of your students ever submitted that you would
Oh,
say, I want this in the Museum of Great Things that my students did?
Yeah, it's a really good question. I mean, actually, some of the MOBOTs were really interesting. They weren't 3D printed; they were more cut. I had one that was, about this size by the time they put it together. What do we got? Okay, so I usually get, besides the phone things, I get headphone stands. Somebody did a toothbrush holder this year. What else do we got? Oh, headphone holders, like where you roll them up or something. So it's really interesting to see how they wrap their heads around that, and actually if they're from different disciplines, to see how they think about this, because everybody's then trying to figure out how it makes sense in their particular discipline. And I mean, it doesn't have to be rigid plastic. There is flexible plastic out there. So I had a medical student, or a nursing student, I think it was, at some point, and she wanted to make a heart or something, and then out of flexible objects as a teaching tool kind of thing. So, yeah. No. All right, well, I'll be around. Catch me if you want. Check this out.